Okay, I'm going to try and do a screencast by presentation on how to do pH calculations for acids and bases. The other day we noticed was that the concentration of acid, concentration of base, the product of these two values is always equal to 1 times 10 to the minus 14th. That is called Kw, or the water ionization constant. So here's an example. If you have a acidic solution, and in that acidic solution, the concentration is going to be greater than 1 times 10 to the minus 7th. So then what happens, here's an example. You've got 0.0001 molar concentration of HCl. That's equal to 1 times 10 to the minus 4th. So if we apply that, we can see that Kw is times 10 to the minus 14th, and the acid is 10 to the minus 4th, we can calculate the hydroxide ion concentration. So if we calculate the hydroxide ion concentration, it's obviously going to be 10 to the minus 10th, 10 to the minus 10th, and 10 to the minus 4th. Those values equal 10 to the minus 14th. So now we've solved for the concentration of the base. Here's an example of a solution where we have the concentration of acid being 0.25 molar. If it's 0.25 molar, we can substitute that in to the equation, and we substitute that in, we can solve for the base concentration. Here, we would solve, and it would be 4 times 10 to the minus 14th molar. So here's that exact problem. Here's the hydrochloric acid. The hydrochloric acid ionizes completely into hydrogen ions and into chloride ions. When we take the hydrochloric acid, it's typically a gas. We actually bubble that gas into solution, and it ionizes completely into chloride ions and hydrogen ions. And so that's what we see here in this container. The concentration of the hydrogen ions is going to be 0.25 molar, as is the concentration of the chloride ions, because we get one of these for each one of the hydrochloric acids. So now, if we look at the concentration of the hydrochloric acid, we simply solve for it using the Kw equation here. 1 times 10 to the minus 14th, concentration of hydrogen ions, which is 0.250. We solve for the hydroxide ion concentration, and this is the resulting concentration of hydroxide ions in this solution. In order to find the pH of an acid, we are going to use this equation. This is going to be pretty useful. You definitely need to understand this equation. pH is equal to the negative log of the concentration of hydroxide ions. So this is a base 10 logarithm calculation. So if I have a solution that is a 0.25 molar hydrochloric acid solution, then that hydrogen ion concentration is 0.25 molar, as we just discussed. If I want to find the pH of it, how do I find that pH? Well, I simply take this hydrogen ion concentration and put that into the concentration here with the negative log of the hydronium ion. And so here it is. We see the negative log. If you look on this video here, you can see how I calculated it in this YouTube video. This will show you step by step how to do that calculation. The resulting pH is 0.6020, which is less than 7. And if it's less than 7, then we know we have an acidic solution. This is actually a very acidic solution. This is the graphic we used last time where we can see that the acid concentration is fairly large over here. This is the acid portion of the graph. This is the base portion of the graph. We have a large base concentration over here, and in the middle we have a neutral pH of 7. First of all, let's take a look at this equation here. This is when we were talking about the Kw is equal to the hydrogen ion concentration times the hydroxide ion concentration. Here you can see, well, let's go to the middle. You have 10 to the minus 7th, 10 to the minus 7th, and so those are the concentrations in a neutral solution. Those equal 10 to the minus 14th. Let's go over here to an acidic solution. Well, if you have an acidic solution, the concentration of hydrogen ions is greater than the concentration of the hydroxide ion concentration. So this is, remember, this is 0.00001, and then this one is 0.000000001. So this is much smaller than this is. It's smaller by a factor of, let's see, 6, 10 to the 6th. So this is going to be an acidic solution. Over here, we look on the basic side. This is the opposite one. You've got a very small concentration of acid. And then over here, you've got a very large concentration of hydroxide ions or base. So this is going to be a basic solution. pH is always calculated based on the hydrogen ion concentration. And so we can see over here then that the pH of 10 corresponds to a hydrogen ion concentration, small hydrogen ion concentration of 10 to the minus 10th. We go to an acidic side. Here's a pH of 2. That corresponds to a hydrogen ion concentration of 10 to the minus 2nd. The other thing you'll notice, of course, is that 14 is the sum of both pH and pOH. pOH being the negative log of the concentration of hydroxide ions. So here's 10, here's 14, or sorry, 4, and obviously 4 and 10 is 14. 7 and 7, 14. 10 and 4 is 14. So we can always, if we're ever given the pH, we can find the pOH. If we're ever given the pOH, we can find the pH. These are going to be useful equations as we move forward. So here's a basic solution, and we're going to solve for pH using, for this basic solution of sodium hydroxide. Sodium hydroxide is a solid. We dissolve it into water, and it separates into ions of sodium and hydroxide. We get 1 sodium ion for every 1, and 1 hydroxide ion for every mole of sodium hydroxide. So a 0.25 molar solution of sodium hydroxide. Initially, there's no sodium and there's no hydroxide, but then after we dissolve it, we have a 0.25 molar solution of sodium and a 0.25 molar solution of hydroxide ions. All right, so mathematically, if we want to calculate the pH, we need the hydrogen ion concentration, since it's the negative log of the hydrogen ion concentration. Right here, what we have is we have the hydroxide ion concentration, which is what we don't need. So we actually have to calculate, using the hydroxide ion concentration, how much hydrogen ion concentration there is. So I'm going to take this 0.25 molar concentration of hydroxides. I'm going to put it into my Kw equation right here, solve for the hydrogen ion concentration. So if I plug that into my calculator, as I did in the previous slide, I get the concentration of hydrogen ions as being 4 times 10 to the minus 14th. Okay. Well, if that's 4 times 10 to the minus 14th, and I want pH, I can now use the negative log of that hydrogen ion concentration. So I'm going to take this value and plug it into for this. So take the negative log of 4 times 10 to the minus 14th, which is the concentration of hydrogen ions. That pH is going to be 13.39. We'll write that as 13.40. Well, that's much larger than 7, and as a consequence, we have a very basic solution right here. And we would expect it to be basic because, of course, sodium hydroxide is a base. So let's say we want to find the pH of a base. So let's say you have a 0.25 molar sodium hydroxide solution. Again, step 1, we're going to solve for the concentration of hydrogen ions using the concentration of base. So I plug in, since the hydroxide ion concentration is 0.050 molar, I plug that in and I solve for the hydrogen ion concentration. That would be 2 times 10 to the minus 13th molar. And then the second thing I have to do is find the pH. So I take this value, the hydrogen ion concentration, I plug that into this equation. This is the negative log of the hydrogen ion concentration. So that would be a negative log of 2 times 10 to the minus 13th. We have a pH now of 12.7, which is greater than 7. And as we anticipate, this would be a basic solution. If you watch this video over here, I will show you step by step how to put that into your calculator. Next, if we want to find the concentration of an acid from pH, then what we're going to do is this is a new equation. Okay, we're going to use this equation here. The hydrogen ion concentration is equal to 10 to the negative pH. Okay, you have to make it a negative pH. This is the reverse of a base 10 logarithm. And so what you're going to do is, if you're given the pH of 4.23, you're going to take that value and plug that in right here. So that would mean that the hydrogen ion concentration is going to be equal to 4 times 10 to the negative 4.23. If you plug that into your calculator, you will get a hydrogen ion concentration that is greater than 10 to the minus 7th. It's 5.89 times 10 to the minus 5th, which is what we would expect in an acidic solution. And so that's what we're going to get here. And if you watch this video here, you will be able to observe how I made those calculations in my calculator. All right, so finding the concentration of an acid from the POH. All right, now if you recall, POH is equal to, POH plus pH equals 14. So if I have a POH of 8.3, I'm going to plug that into this equation right here, and then solve for the pH. So 14 minus 8.3 is 5.7. So that's a pretty easy calculation to get pH. So if I want to find the concentration of acid, then I'm going to use the previous equation. I'm going to take this value, I'm going to plug it into 10 to the minus pH. So the hydrogen ion concentration is going to be equal to 10 to the negative 5.7. 10 to the minus 5.7. If I take this, I plug it in my calculator, and you can see how I did that over in this video here, is going to be 2.00 times 10 to the minus 6 molar. 10 to the minus 6 molar is greater than 10 to the minus 7th molar. Therefore, this would be an acidic solution. And we'd expect it to be acidic because the pH is 5.7 and the POH is 8.3. So let's take another look at something. Here's a POH of a base. So this particular one is 0.004 molar calcium hydroxide. But the thing about the calcium hydroxide, it's a twofer. You get 2 hydroxides for every calcium hydroxide. Okay, well, what does that mean? Well, that means when this dissolves in a solution, I have 0.004 molar calcium ions, but I have to double the concentration of hydroxide ions. So that's 0.008. There it is, multiply it by 2. If I want to get the POH, then I'm simply going to take, the negative log of the hydroxide ion concentration, and which we determined was 0.008. I plug that in here. I get a POH of 2.10, but nobody talks about POH, right? So they only talk about pH. So what can I do? I can take 14 minus POH and get my pH, which is 11.90. Now, a pH of 11.90, that, of course, is basic, and this is a base, so we look at this and we say, yeah, I probably calculated that correctly. All right, that is the end of the presentation.